Hello everybody, I'm Philip Jonas at Kalamazoo Valley Community College, presenting OpenStax Principles of Economics, and today we're covering modules 8.2 through 8.4, Profit Max, Shutdown, Entry, and Exit. In this module, you will learn how to use marginal analysis to determine profit max, how to identify the short-run shutdown point, explain the long-run entry and exit decisions, and evaluate efficiency in perfect competition. So today we've got a number of business rules to get through and how economics applies to decision making at the individual business level, and we will start by talking about profit maximization. It is, of course, our continued assumption that firms exist to maximize their profits. As we talk about these rules, it's handy to keep in mind which of these rules operate at the margin versus on average. So starting out with profit maximization, this is one of our rules that uses marginal analysis. So if we look at our formula for profit in general, total revenue minus total cost, let's start out and take those two concepts and represent their marginal equivalents. On the marginal revenue side, we've got the change in total cost over the change in quantity, and then over on the change in cost over change in quantity side, giving us marginal cost. Now, when we are looking at that profit on our graphs on a per unit basis, it'll also be handy to take that profit formula and slightly reformulate it. We can take quantity as a common factor out of our total revenue and total cost, factor that out of both, and you end up with price minus average total cost times quantity, also giving us profit. That'll come in handy. But first, let's cover our profit max rule. So let's put the rule right up front in a big yellow box. The rule is choose quantity for your business where marginal revenue equals marginal cost. And we're going to take a look in just a second at why that works. Now, when we get to business types later that are not in perfect competition, there will be a second step to that profit max rule where after choosing our quantity, we have to choose the price for our product. But we're not going to talk about that yet because in perfect competition, individual firms are of course price takers, and that means they don't get to choose a price. This also makes it easier to learn about the rule because right now we only have one thing to worry about, and that is choosing the correct quantity. So let's start out by looking at this graphically. First, a reminder, since we are looking at price takers in perfectly competitive markets, where does the price come from? Well, the answer is, of course, the market. So we have some supply and demand curves at the market level that form an equilibrium, and in this example give us a price of $4 per pack of raspberries. And we now want to take that price here and take it into the decision making at the individual firm level. So here is the marginal cost curve from our raspberry merchant that we looked at in our last module. Reminder, that marginal cost curve, after a little while of falling and rising again, eventually escalates very quickly. A common feature of short-run marginal cost curves as you run into some type of fixed constraint of your business. So this is one half of our rule, the marginal cost curve. It describes the firm itself. And now we want to bring into this picture the marginal revenue of the business. So again, we're talking about perfect competition, and in perfect competition, the price set at the market level becomes marginal revenue at the individual firm level. So let's go ahead and draw in $4 as our marginal revenue curve. And this curve, of course, very distinct shape in perfect competition. It's in fact a horizontal line. So here we've got marginal revenue for our first example at $4. You can already see we've got an intersection here at 80 units. We previously identified that the firm was maximizing its profits at 80, but now you can see that actually playing out using this rule. We'll be doing a lot of that today using graphs, but I think it's great to start out by looking at these numbers in the form of a table instead, just to get familiar with some of the basic mechanics at work here. So let's say goodbye to the graph for just a second and head on over to identifying this profit maximizing point on our table. So here are the total revenue and total cost of our Raspberry firm from the last module. And then for our reference, I've already filled in for you marginal revenue. Notice, of course, that's a constant number all the way down. Again, price taker, perfect competition. And then we've got marginal cost decreasing and then escalating very quickly. Now, if you look simply at the calculation of profit as total revenue minus total cost, you can of course just sort of eyeball here, hey, look at these two rows where we've got the biggest number, and you already know where this is going. I'm actually going to identify the 80 quantity row here with $90 as profit max. I'll talk in just a second about why I would choose this row. But first, let's talk about what makes this profit max rule work. So profit max is a rule that works at the margin. We're using marginal analysis, which means we're thinking about an optimization problem stepwise, asking ourselves with every incrementally changed decision, are we approaching our goal or are we moving away from it? So let's not look at the 80 quantity quite yet, but let's look at lower quantities before that. Up here in our table, if you compare marginal revenue and marginal cost, you notice that marginal cost is always lower. So what that means is, in terms of a marginal analysis, every time you take a step forward in this table, one row down if you will, you're contributing to your profit, because at the margin, as you're producing 10 more packs of raspberries at a time, the additional revenue that these raspberries bring in exceed the additional cost. For example, if we look at quantity row 30 and ask ourselves what happens if we advance to 40, so that's 10 more units. Going from 30 to 40, let's look at our marginal revenue. We're getting $4 per pack. Let's look at our marginal cost. Cost is only increasing $1.20 per pack. So that of course means per pack, we are contributing $2.80 to our profit. And since it's a 10-pack step on our table, that's the smallest sort of unit of analysis that's available to us, we're contributing 10 times $2.80 to our profit, or $28. So let's look at the profit numbers, make sure this checks out. Going from 30 to 40, our profit increases from -6 to 22, which is of course exactly that $28 increase. That's how marginal analysis works. So we're stepping and stepping and stepping as long as marginal revenue exceeds marginal cost, until we reach our profit max row. We'll get back to that in just a second, because of course marginal analysis works from both directions. We could also look at, what if we're currently at a much higher level of production here at the 90 or 100 level? So that means we're making raspberries where, even if overall we're making a profit, the most recent ones we made cost more than they brought in. They actually took away from our profit. So that's why at these high levels here, where marginal cost exceeds marginal revenue, we actually want to step back and decrease production. So you put both of those statements together. As long as marginal revenue exceeds marginal cost, our profit is increasing. On the other hand, while marginal cost exceeds marginal revenue, our profit is decreasing. If we follow both of those guideposts, if you will, it's directing us to the row where marginal revenue is equal to marginal cost. And that's the result here. A maximum for profit implies that you're at a point where marginal revenue is equal to marginal cost. All right, now I know some of you are wondering, so let's get back to that. What about the row right before it, the 70, right? So what marginal revenue equals marginal cost here shows us is, if we go from 70 to 80, those last 10 packs, revenue is exactly equal to cost. So a couple of things about that. Number one, of course, to an extent, I've got this table like this because I want there to be the exact equality for you to see it, right? Like quite often when you just use real numbers, you'll instead have a number of rows where marginal revenue exceeds marginal cost, and then it flips where marginal cost is greater than marginal revenue. So you would stop at the last row where marginal revenue is still equal to marginal cost. But let's look at this special case. Let's not dodge the question, right? What if they're exactly equal? What about those last two rows? Well, if you want to be really technical about it, you do want to pick the second one of those rows. So in this case, quantity 80, with that second time that profit is equal to $90, the exact row where marginal revenue equals marginal cost. And that has to do, we haven't talked about it in detail, with the definition of cost in economics. So when we calculate cost, we use a concept called opportunity cost. And that basically means your cost of pursuing an action is the next best alternative for those resources. So if you have an opportunity to take an action where the marginal benefit is equal to the marginal cost, you are in fact choosing the option that has the highest possible value, and it's still worth it. Like right on the edge, but still worth it. So technically marginal revenue equals marginal cost. That's still a yes. And in this case, I'd want you to indicate 80 quantity as the correct answer to the profit max question. So hopefully looking at this in table form makes it a little bit easier to see the mechanics of marginal analysis in action. But let's go ahead and dive a little bit deeper into the profit max question, because marginal analysis, it's super powerful, right? It lets us just operate from our current point. Hey, here's where I am. Let's look at the margin this way. Let's look at the margin this way. And then you take steps to improve your position. However, because we are looking at this problem from the inside out, if you will, identifying a profit max, this will sound a little weird, doesn't automatically assure that that's a positive number for profit. Because with marginal analysis, it can only tell you, is it getting better or is it getting worse? It doesn't tell you the overall condition of the firm, right? Literally the information on things such as fixed cost isn't within the marginal numbers. So for that, we need to look on average, and I already foreshadowed this a little bit. The easiest way to combine this with our profit max rule is to use a formula for profit where instead of just saying total revenue minus total cost, we actually express this on average instead. And we say profit can also be thought of as price, aka average revenue, minus average total cost. And then that difference, which you could call average profit, if you will, times quantity. And of course, I'll show you how to integrate that with the profit max rule in just a second. But let's orient ourselves a little bit with how this formula works. Since quantity is always a positive number or maybe zero if we're shut down, but it's not like we can produce negative quantities, that means it's still really easy to see what sort of profit condition you're in just based on price and average total cost. If price is greater than average total cost, we're earning a positive profit. Price is smaller than average total cost, we're earning a negative profit, aka a loss. So keep this in the back of your mind. Price greater than average total cost, profit. Price less than average total cost, loss. And now let's get back to our table of identifying profit max. So in this table now, you'll have noticed a small change. I'm no longer giving you total revenue, total cost, and profit because I want you to start thinking on average. And looking at our price and average total cost numbers, hopefully it's becoming sort of familiar to you here. As long as average total cost is greater than price, company is losing money. When price exceeds average total cost, average profit is positive, company is making money. But marginal analysis helps us find the most money. Marginal analysis, of course, says profit max is where marginal revenue equals marginal cost. So at 80 units, same as before, And we can do a little check here, but are we actually earning a profit? Answer yes, because price exceeds average total cost. Average profit is $1.12 per Raspberry Pack. Notice, maximum profit does not necessarily occur where this margin, where average profit is the biggest. Average profit per unit is actually higher at lower levels, but the most profit happens at 80. So let's go ahead and plug this into our formula as well. So we can take 4 minus 288, that's $1.12 in average profit, and then multiply by quantity to get the profit back out. Now, it doesn't come out to be exactly $90 because we're rounding. We're going to just 2 cents, right? So we're losing a little bit of information. But after rounding, there is the $90 profit that our firm is earning. So what does this do for us? Why are we looking at this on average? Well, check this out. Here's a firm with its cost expressed in both perspectives we're going to use. Marginal perspective, so marginal cost, showing us the cost of making an additional unit, incremental. Average cost. Average cost is showing us average total cost in general, which is our cost across all units averaged out. So here, imagine we're looking at our perfectly competitive company, and I'm now bringing in the price from market supply and market demand to become marginal revenue for our individual firm. Horizontal line, because we are a price taker. Notice, price has changed. This time it isn't $4, it's $5. Let me show you both types of analysis in order now. Step number 1, we use the profit max rule to identify how much we should produce. Profit max rule. Marginal revenue equals marginal cost. So we look for our marginal lines. Right here they intersect. And you can tell our profit max sits a little more than 80 units in. It's a number we don't even have on the table, right? If you know how to do this graphical analysis, you can find any very specific profit max point based on the lines available to you. So that's how you identify the quantity. And then step number 2, we can now check in and say, so is this company actually making a profit at this profit maximum? And for that, we need to look on average. So number 1, we look at the price. Well, price for a perfectly competitive company is the same as marginal revenue. Okay, so we already have the price, it's $5. But then at that profit maximizing quantity, so you got to make sure to go exactly vertically up or down from your profit max quantity here. Check your average total cost curve and see where that average total cost is. So you see that's a little north of $3 here. And since price is greater than average total cost, this firm is in fact making a profit. So what this average perspective lets us do is put both the where is my profit max question and am I making a profit overall into one graph, into one analysis. That's why we're doing it using per unit on both sides, marginal and average. And you can actually do one better. This is kind of cool because price minus average total cost is average profit. So whatever difference we have between $5 and our average total cost here is profit per unit. You know how to go from profit per unit to total profit. The second step in our profit formula would be price minus the average total cost times quantity. We know our quantity on this picture as well. It's, right here, a little over 80. So what we can do on our graph is we can take this vertical distance here between price and average total cost, We can multiply it by this horizontal distance, this x-axis here. Here's how much quantity is being produced. You take a vertical times a horizontal. What do you get? You get an area, and that area lets you find the profit of the firm. So even the profit as a total number is on this graph, but because we're doing things on a per unit basis, it's on the graph as an area. You have to multiply your per units by a quantity to get the total back out. You want to do it again? Let's do it again. All right, so here's our raspberry merchant again, but now demand for raspberries has fallen and the price we bring in from the market is only $2 per pack. Again, multi-step process. Step number 1, identify profit max. So that happens at the margin, where marginal revenue equals marginal cost. That's your profit max. And then step number 2, now look at the averages. In perfect competition, marginal revenue also happens to be price, so it's both an average and a marginal. It's because every number is the same, right? If everything is 2, 2, 2, 2, 2, then at the margin it's 2, but on average it's also 2. But look where our average total cost comes in now. It's a number bigger than $2. So that lets us know, even though at a little over 60 units here, this is the maximum number for profit, this time around it isn't a positive number, it's a negative number. We can still identify the profit as well. Same formula as before. Price minus average total cost, that gives us profit per unit. You can already tell that's a negative number this time, right? Then we multiply by the x span, going from 0 to a little over 60 units. Height times width. We once again get ourselves a rectangle. This time around a rectangle that has a negative size to it, if you would like to think of it in that fashion. So that's our profit maximization rule. And as this graph here demonstrates, it reliably finds profit max, but that profit max is not necessarily a positive number. So what that means is, even though profit max works, it doesn't necessarily let us know if we should be in business to begin with. We're going to look at that next, which of course means we have to look a little bit more on the average side of our cost and yes, our revenue as well. So in order to fully make sense of what's about to be happening there, I have to let you know about a special relationship that our two per unit cost curves share. One more time, here we've got marginal cost. That's the cost of one more unit, of an incremental unit. What does it cost me to increase production? And then we've got our average cost. What's the cost divided by all units that I'm producing, on average? And the special relationship I want to show you is they intersect at a very special point called the efficient scale. So what's going on here is, imagine we are not yet at this special point, the efficient scale, but somewhere before it. Like let's say we're making 40 units at the moment. So at that point you can tell the marginal cost of production, so the cost of unit 40 specifically, if you will, is lower than the average cost of production across all 40 units. When that is the case, when the cost of an additional unit is less than the cost of your average unit so far, producing that additional lower cost unit lowers your average cost. Now, for some of you that might make immediate sense, but if it's not quite clicking, this marginal versus average principle applies not just when it comes to firm costs, but to any averages. So for example, imagine you have a classroom with a certain average grade. So that's an average concept, right? We're taking everybody's grades, adding them up, dividing them by the classroom. But now we are adding an additional student, like this example right here, where that additional student's grade is below the average. What happens to the average when we add that student? Average goes down. Or imagine you are looking at some other type of average, like for example, a score, right? Like on average, how often do you manage to achieve a point in a game? Maybe, 50% of the time. If you now add games where you're doing worse, you're only scoring 30% of the time. Your average will drop because of the lower incrementals. And then, of course, if we are beyond this intersection, marginal is greater than average. So here's unit number 100. The cost of unit number 100 specifically, the marginal cost, is higher than the average cost of all 100 units. You do that, you have got yourself a marginal that's greater than the average. That'll make your average go up. Same with a class. Add a student that has an above average grade, average goes up. Same with a game. Play around where your score percentage is higher than 50%, your average goes up from 50%. So if you put both of those things together, when marginal cost is below average total cost, it drags the average down, and when it exceeds marginal cost, it starts pulling the average up. Put those two together, of course, it implies that at the minimum of the average total cost curve, the marginal and the average are exactly equal. This is referred to as the efficient scale of a firm, where average cost is minimized. And it happens at the point where marginal cost is equal to average cost. So not only do we have per unit cost in two flavors, marginal and average, they share an important relationship that you're going to see in action in just a minute. So let's go ahead and look at our very first example of this. How is a perfectly competitive firm doing when it is producing at the efficient scale? So first of all, we're sort of operating this one backwards, right? How does a perfectly competitive firm decide how much to produce? Well, where marginal revenue equals marginal cost, right? So in order for the firm to make this decision to begin with, we need our marginal revenue, our market price, to come in exactly at this point where marginal cost and average cost intersect. And what we discover now is, oh, look at that. So this is the lowest average cost the firm can produce at. If a perfectly competitive firm is producing at the lowest possible average total cost, it must be because they are just breaking even there. Right? Because at that minimum, that's the only point where you're going to get MR equals MC for your profit max condition, and then also MC equals ATC for your minimum average total cost, for your efficient scale. So if we were to calculate the profit of this firm, we would of course find a zero, because price and average total cost are the same number, so average profit is zero. So do perfectly competitive firms produce at their efficient scale? Yeah, sure, all the time, but it means in an economic sense, they are just breaking even and not earning an economic profit. The intersection between marginal and average total cost does even more for us than that. But to look at it in greater detail, it is time for us to learn about our next business rule, the shutdown rule. All right, so let's be really precise what shutdown means here. Shutdown is a condition where your business very much still exists. It's not going out of business, but it's producing nothing. It's at quantity zero. It's suspended, if you will. It's shut down. Now, this shutdown rule comes up much more often than you might think at first, because many businesses aren't continuously operating. So the shutdown rule might be something you rely on just to decide when you want your business to be open. Like if you're not open 24 hours, then at night you are shut down. You're not getting rid of the business, you're just sort of turning it off and turning it back on in the morning. So this can be relevant on a daily basis. It can be relevant throughout the week. Do you want to be open all days of the week? It can be relevant seasonally, for example. What if you are operating a business in a place that's got a strong tourist season? Then during the off season, you have to make a decision. Does it even make sense for this business to be open during the off season, or should I shut it down? The shutdown rule uses average analysis. Specifically, over on the revenue side, we've got average revenue as always, which is of course usually referred to just as price, because with a single price business, the average revenue always simplifies down to price. And then over on the cost side, for our shutdown rule, we'll be looking at average variable cost. I'll show you in a second why that's the relevant concept. In order to make sense of that, let us also look at what shutdown implies. Being shut down means we are looking at quantity equals zero. And of course, if we look at our profit formula, a couple things happen there. On the revenue side, price times quantity. If quantity is zero, revenue is zero. If you're shut down, nobody's giving you money. And as you probably remember from our last module on cost, especially if you had to answer some questions about it, it's key to remember that when quantity is zero, when we're shut down, variable cost is by definition $0. The only costs that occur during shutdown are by definition fixed cost. And that really is the key to the shutdown decision. Realizing what cost you can do away with during a shutdown. Variable cost goes away. You can send your employees home, for example, but the fixed cost remain. Because with this framework, we can now basically do a little comparison. In the short run, should I be open at night on Monday during the off season, whatever we're thinking about? Well, it's actually just a cost-benefit analysis. We should identify the course of action that gives us the most profit we can earn. So under both conditions, operate or shut down, profit is, of course, total revenue minus total cost. But let me split that up a little bit, because as I mentioned, it's really important for the shutdown rule to think about that fixed cost and how it behaves under our two alternatives. So let me split up our total cost into variable cost and fixed cost. Convince yourself, it's still the same formula. Profit is total revenue minus variable cost minus fixed cost. And now let's plug in some numbers. On the right, if a firm is shut down, what is total revenue? Well, since quantity is zero, P times quantity, total revenue drops to zero. Likewise, what is variable cost? Well, by definition, if you're shut down, variable cost is zero. So let's plug that in and compare our two possible outcomes. If we shut the company down, no revenue, no variable cost, conclusion, profit will be equal to negative fixed cost. Whatever the fixed cost of our business, we're now losing that money. So we want to compare that to what happens when we operate over here. When we operate, we are also losing our fixed cost. So here comes the key thought now. We are paying for fixed cost whether we're shut down or we're operating. That means the fixed costs are irrelevant for this decision. Anytime you have a cost that exists on both branches of a decision, that cost is not relevant for your decision because you have to pay it either way. We sometimes refer to that as a sunk cost in economics, a cost that cannot be recovered. Which means over on the operate side, there's really only one question. So what about total revenue minus variable cost? If we look at just the pieces that matter, if you will, because they are different between the decision, we discover it's really simple to identify if you should shut down or not. If your total revenue exceeds your variable cost, then we've got something a little bit better than a zero over here. So operate the business. But if total revenue is less than variable cost, we end up with something less than zero over here. And that means, oh man, being shut down might also be bad, but it's better because all we're losing is our fixed cost as opposed to additional losses on top of that. And then once again, in case you care about that razor's edge situation, yes, because of the way we define opportunity cost, if total revenue is equal to variable cost, we are still in the operate side of our ledger here. Now, same as before, we want to express this relationship on a per unit basis so that we can nicely integrate it with our profit max rule. So let me go ahead and take these inequalities and divide them by quantity. We want to operate if price is greater than or equal to average variable cost. We want to shut down if price is less than average variable cost. So that's our second business rule. First rule was, how do I maximize profits? Choose quantity where marginal revenue equals marginal cost. Second rule, do I want to operate at that profit max or do I want to shut the company down? Answer, look at price and average variable cost because the fixed costs don't matter. Average variable cost. If price is less than average variable cost, shut it down. So with both of these rules in our toolkit, we can now do an even more comprehensive analysis of our Raspberry business. So here it is again, the marginal and average total cost, quite familiar, and now with the average variable cost curve added. Let's bring in a potential marginal revenue at a little over $2. And now we're going to answer 3 questions. Number 1, where is the profit max? Marginal analysis. Look at the intersection of marginal revenue and marginal cost. A little more than 60 units here is our profit max. Second question. Is the firm profitable? Compare price at a little over $2 and average total cost. Average total cost is higher. Answer, no, the firm is not profitable. Number 3, so should we shut the firm down? For that one, compare price and average variable cost. Answer, no, we should continue to operate because price is greater than average variable cost. You want to do it again? Let's do it again. So, same Raspberry firm. This time around, marginal revenue is all the way down there. So let's look at our questions. Question number 1. How much should this firm produce to maximize profits? Well, at first glance, little under 60 units. Question number 2. Would the firm be operating at a profit at this level? Price, average total cost? No, price is below average total cost, profits will be negative. Third question, so should the business operate? Price and average variable cost. Look at the price. Look at the average variable cost. Ooh, prices beneath average variable cost. Never mind, shut the business down. We'll be losing less money if we go into shutdown. That's why at the beginning here I said profit max indicates that maybe we should produce a little under 60 units because that's where MR is equal to MC. But in the picture you're looking at here, actually below that, the shutdown rule overrides. Don't produce a little under 60, produce 0 units because you want to shut down. And shutdown is 0 production. So at this point, we have 3 wonderful business rules that integrate with each other. Let's do it again, completely in the abstract. Forget about the Raspberry Merchant. Here are all the per unit cost concepts you need to make your business decisions. Marginal cost. Reminder, that one tells you where your profit max is in terms of quantity production. Average total cost. That one, by comparing it to the price of your product, lets you know if you're earning a profit. And average variable cost. It's that one that lets you know, when compared to the price of your product, if you should be producing in the first place, or if you should override that profit max rule and shut the business down. So again, as a price taker, looking at a perfectly competitive market, price equals marginal revenue just sort of comes in from the supply and demand model. You can't choose that. There's a horizontal line that could be coming in at many different levels. But these 3 curves let you know what to do no matter where that line comes in. You can almost think of it as ranges. So if marginal revenue comes in somewhere up here, somewhere over here, if you will, you are in the profit zone. Anywhere up here, intersection with marginal cost gives you profit max quantity, and because the price is well north of average total cost, you are earning a profit. So in other words, you can think of this section of the marginal cost curve here as all the possible production decisions you'll make if price comes in anywhere at this level. It's like all the decisions are already made for you. And as long as you're above average total cost, you're also earning a profit. So now let's think of this in terms of a falling price. Eventually, you get to the point where marginal cost is equal to average total cost. Reminder, we call that the efficient scale of our business. And also, it means that at this point, you're no longer earning a profit in the economic sense. You are breaking even. Once price comes in at below this number, you will be forced below your average total cost curve. That means at this point, you are earning losses. You're no longer breaking even. Again, anywhere south of average total cost, price comes in down here, you're earning losses. But you're not yet shutting down. For that one, we'll be looking at average variable cost. So anywhere on this section, continue to look at marginal cost to identify your profit maximizing quantity, produce there, even though the profit maximizing amount will now be a negative number. Until you get to the intersection of marginal cost and average variable cost, that's your shutdown point. So like right at that point, where price equal average variable cost, you're still operating. That's the very lowest price where you still want to operate. And as soon as you fall below that shutdown point, here if you will, do not look at marginal cost anymore for a profit maximizing quantity. I mean, it would still be the profit maximizing quantity if you operate it. Like, it's not like the marginal cost curve is broken or anything. But if you are anywhere down here, you don't want to produce this quantity. You want to take quantity down to 0. The shutdown rule overrides. So here we are one more time. three possible decision ranges based on the price equals marginal revenue of your product. Anywhere up here, profits. Anywhere here, losses but operate. Anywhere here, shut it down. All right, this now, what you're looking at, is the entire short-run decision-making set of your business. All that's left to talk about are the long-run decisions. So what do we mean here in economics when we say long run? It means there exists a time frame where a business is no longer fixed in some way. All the costs that it has can be changed. If you want to get out of business, you can. And also, if other firms want to get into this business, they can also come in. For these long-run decisions, we will once again be operating using averages. Now, the long-run versus short-run time frame, it depends on the specific industry you're in. But basically what we're talking about is, if you've got a store and you want to decide, do I want to be open at night? Assuming you want to reopen in the morning, that's a short-run decision. All you can do overnight is shut down or operate. You cannot sell your store at 5 p.m. and then buy it back at 9 a.m., do an exit and an entry. That will be a long-run decision. That's basically the difference between these two time frames. Can you choose to just get rid of your business or completely reorganize the business or freshly get into the business? So for this long-run decision-making, we are going to be using averages. Once again, average revenue will simply be price, and we'll be looking at average total cost. Here's how this works. If the firms that currently exist are earning profit, looking at our average profit formula, that means currently price is above average total cost. Now you'll notice the yellow box. That means it's a rule. How is just earning profits a rule? Well, the rule is, the rule of capitalism, if you will, that in the long run, if profits are to be made, new firms enter the market. Price greater than average total cost is the entry rule. So it's a rule not for the companies that are already in the market. They are simply earning a profit and having a good time. It's a rule for firms that aren't in the market. It's time to get in. And of course, as we learned quite some time ago, when new firms enter a market, this increases the market supply. If you look at the supply and demand diagram, when supply increases, price goes down. So this average profit, this profit that the firms in the market are earning, it's getting smaller. New competition is squeezing it. And you can probably already anticipate where this is going. But let's look at all the possible flavors of this. So, second possibility, the firms that are already in the market might be earning losses. And losses, of course, mean that price is currently under average total cost. Price minus average total cost gives you now a negative number. So this is a rule for the existing businesses in here. In the long run, if you keep earning losses, it's time to get out. Price less than average total cost is the exit rule. And of course, as we learned quite some time ago, if companies exit a market, that decreases market supply. So now prices are going to start climbing. You can't have sustainable prices where everybody's losing money, right? The companies will go out of business. So let's put this together for perfect competition. If price is above average total cost and profits are being earned, competition enters and pushes the price down. If price is below average total cost and losses are triggered, companies get out, making prices go up. So neither one of those conditions are long-run stable. The long-run stable condition is price equals average total cost. Only then is neither the entry nor the exit rule triggered. And what that of course means is, if we look at our profit formula, price minus average total cost, if those two numbers are equal, now it's zero, right? What that means is, of course, the market stabilizes at break even. Everybody in there is earning zero economic profits. And that has some interesting implications for the long run condition of perfectly competitive markets. So before we get to those, if the break even is the long run outcome of a perfectly competitive market, then what determines the price of the product? In the long run, it's what we call the long run supply curve. It's the supply curve that shows us the prices at which all the companies are breaking even. And in some industries, that's a horizontal line. That's a so-called constant cost industry. If there are more companies or fewer companies, it doesn't really change the cost structure of that market. But other industries, for example, if the product gets really big, if we have lots of companies entering, lots of consumers being served, they might be competing over a limited resource to make the product. And the bigger the market gets, the more prices might actually go up. Or other markets, I think technology might be a really great example. As the markets get bigger, it actually becomes easier to produce more and cost come down. So this long run supply curve, it can have many different shapes, but it's defined where there is zero economic profit. So let's go ahead and think about the implications for this for perfect competition. So remember, in perfect competition, our firms are price takers. That means price is equal to marginal revenue. That's only true for price takers. It will not be true for all industry types we look at. But what is true for all industry types is that profits are maximized where marginal revenue equals marginal cost. Well, if we look at this long-run break-even condition, price equals average total cost, but we're doing it in a context where price is also equal to marginal revenue and marginal revenue is equal to marginal cost, then in our long-run stable situation, we end up with a whole bunch of stuff that's equal to one another and actually represents some important results in microeconomics. The first is what we call productive efficiency. Competitive markets are productively efficient. What that means is, at price equals average total cost. We looked at that a minute ago. For perfectly competitive companies where price equals average total cost, that's a point where the marginal cost curve intersects the average total cost curve. And that means we are producing at minimum average total cost. We are productively efficient. You can also, without the curves, just do that directly from the math here. If price equals marginal revenue and marginal revenue equals marginal cost, that means price is going to be equal to marginal cost and average total cost. Therefore, marginal cost is equal to average total cost. Boom, there we are. We're at the minimum of our average total cost curve. And we get a second type of efficiency out of perfectly competitive markets. It's called allocative efficiency. Allocative efficiency refers to, is the market producing enough of this product for everybody where the willingness to pay is equal to or greater than the cost of production. You do that analysis by looking at price and marginal cost. In an allocatively efficient market, you want every unit to be produced where the price is greater than or equal to the marginal cost, and boom, once again, perfectly competitive markets do that for us. So as always, you can ask some questions here to what extent the real world in any given situation resembles a perfectly competitive market. But if it does, we get some super results. In the long run, all the firms in this market are being squeezed to zero economic profit. They're being forced to produce at minimum average total cost, which is what we call productive efficiency. And they are producing enough so that everybody who values the product equal to or greater than the cost of production actually gets the product. And that's what we call allocative efficiency. And that's what makes perfectly competitive markets pretty cool. And some of the markets we look at in the future module, not as cool, because, for example, a monopoly will not behave nicely like this. But for now, we've discussed perfectly competitive markets, so let's wrap that up. In this module, you learned how to use marginal analysis to determine the profit maximizing quantity, how to identify the short-run shutdown point, how to explain the long-run entry and exit decisions, and how to evaluate efficiency in perfect competition. I will see you next time.